Hi everyone, welcome to my special topics presentation titled PGX Testing, Environmental Factors, and Within Racial Group Baselines. This presentation is structured as outlined on the slide. The nature of the topic I chose does not lend perfectly to the assignment rubric because my topic is not explicitly focused on a condition or drug class, but I was still able to adapt my presentation on the topic to the rubric pretty well. So why did I choose this topic? First, because my commitment as a nurse is always to be uniquely responsive to the needs of folks in my community of origin, working poor people and people of color. Second, because I found Dr. Hamilton's Week 2 Pharmacogenetics Overview lecture and the related assigned readings super interesting, especially when I consider them from the lens of my nursing commitment. More specifically, in Dr. Hamilton's lecture, in discussing the most common allele in the white population, CYP2D6 alleles, he mentioned that white people are typically used as a reference group because they are the population on whom drug baselines are usually developed. Similarly, he noted that the medication dosing schedules seen in the research literature are developed relative to the white population as well. These points piqued my curiosity because Dr. Hamilton's previous lectures and in our assigned readings, including in the stall text, I noticed that in the discussion of genes and the potential pharmacological manipulations of genes, attention to environmental factors, education, socioeconomic status, trauma, genetics, diet, and gender figured prominently. So why, I wondered, is biomedical research and the PGX testing industry using only one group, white people, to establish baselines for pharmacogenetic testing and drug dosing schedules, and then seemingly assuming that these baselines and schedules are appropriate and adequate for treating application cross-racially in all groups? This is what led me to post the question outlined on the slide in our class cafe in May. Some of you may have seen the post, as well as Dr. Hamilton's response outlined in this slide. Heeding Dr. Hamilton's suggestion, I went to the website for all three of the big three PGX testing vendors. I noted that the Assurix site is not user-friendly for clinicians or clients. It seems to be designed primarily to get people, whether clinicians or clients, to sign up in order to get more information. There's nowhere else to go from the home page. The Millennial site has a user-friendly design directed at clients. Fortunately, the Genomind site has a user-friendly design differentiated for both clinicians and clients, so I was able to spend some time reviewing what I could immediately access from site. When it came time to email Dr. Hamilton about a topic for this presentation, it was almost inevitable that I would revisit the topic I chose. Fortunately, as outlined on the slide, Dr. Hamilton approved my proposed topic. Heeding Dr. Hamilton's advice further, I read the article noted he sent me and emailed Genomind to request any literature they had about establishing within racial group baselines for pharmacogenomic testing. A few days later, I received an 86-page annotated bibliography entitled Summary of Literature and Clinical Impact, comprised of 344 studies. The bibliography is divided into three main categories as outlined on top of the slide. Using race and racial as search terms, I reviewed the bibliography and found no mention of race and one reference to racial and the word interracial in an article by Roy et al. About CYP3A5, genetic polymorphisms in different ethnic populations situated in the research on pharmacodynamic genes. The article concludes that while there is an interracial genetic variation within the CYP3A5 gene among white and African populations, it attributes this variation to likely evolutionary pressures generated by environmental factors in geographically distinct regions. This article revealed concerns related to my topic in its conflation of race, ethnicity, color, ancestry, nationality, and geography. For example, it describes one group as white and another as African rather than, for example, the opposite, black and European. Later, it refers to the group as white, Canadian, and Zimbabweans, which implies that all Canadians are not white, but that all Zimbabweans are black. Further, the article title implies that the study focuses on ethnic populations but describes an interracial genetic variation. Finally, after describing the variation, the genetic nature of it's largely dismissed in favor of evolutionary, environmental, and geographic explanations. Sujin Lee argues that conflating only client race and ethnicity can lead to radically different responses to medications. While some of these responses can be ascribed to known genes, when they are viewed through the lens of race or ethnicity, their causes are still unknown. Hence, associating race and the genes that they convey disease and drug reactivity is problematic. Using these concerns as springboard into my topic introductions, the questions outlined on the bottom of the slide came to mind. I decided to focus my presentation topic on PGX testing, environmental factors, and within racial group baselines. more specifically, the complex relationship between pharmacogenetics, race, and psychiatry. In so doing, I discovered that there is a lot of debate about the ethics of race-focused baselines, which I categorize into three strands outlined on the slide. I will organize my synopsis discussion around objectives 1 and 2, my applications discussion around objective 3, and use objective 4 to initiate the critical reflection and dialogue in the discussion forum. According to Pong, and Clark, the modern concept of race likely first emerged in the work of 18th century naturalist Carl Linnaeus and his protege Friedrich Blumenbach. Linnaeus made racial distinctions between human groups. Blumenbach generated racial hierarchies. Linnaeus's distinctions and Blumenbach's hierarchies were based on their personal biases and biases of other Europeans during the so-called Enlightenment period. Sociologists have documented how these biases became an integral part of European and later European American xenophobia and racism. Anthropologist Ashley Montagu is credited with bringing the study of race and related politics into science realms and challenging the efficacy of race as a biological construct, notably in his 1942 work, Man's Most Dangerous Myth, The Fallacy of Race. While the use of Linnaeus's racial categorizations and at least covert adherence to Blumenbach's beliefs about racial hierarchies are still pervasive in mainstream U.S. culture today, thanks to Montagu and later to evolutionary biologist and paleontologist Stephen Jay Gould, among others, modern scientists the world over have proven using multiple lines of evidence that there is no biological basis for race. But while the scientific community has proven in multiple studies that the concept of race has absolutely no basis in biology, because individual scientists are members of society, they may unknowingly, unintentionally, or due to conventional or their own biases, group individuals according to self-reported and or scientist-assumed race. To categorize people based on race not only ignores the complexities of human evolution, but can lead to false correlations between disease states, drug interactions, etc. According to Kremsky, because self-identified or sociopolitically imposed racial identity is neither standardized nor reliable, then any science that derives from it cannot be reliable. Indeed, people's racial self-identity can change with the circumstances, including sociopolitical shifts. For example, following slavery in the United States, state laws dictated racial identity by percentage admixture. Thus, today, a person who self-identifies as African American could have one great-grandfather, or about 1/8 of his or her genome, as the exclusive source of that identity. The reliability of self-identification as a proxy for racial or ethnic identity was called into question in the 1970s after the U.S. Census Bureau did follow-up interviews to assess the consistency of self-reporting and found that 34% of respondents changed their ethnic or racial identity within 2 years. In the 2000 U.S. Census, 7 million people identified themselves as more than one race, or 800,000 respondents claimed to be black and white. So race is a social and political construct. Critical legal scholar Ian Haney Lopez explains that this means that though race is not a tangible, concrete reality because of its deep entrenchment in past and continuing human biases, it is treated in society as though it is. As a result, race operates within society with devastatingly negative consequences. According to Sujin Lee, despite the false reality of race and the associated negative consequences of its continued reification, racial self-identification is common, typically because it is associated with culture, cultural traditions, and cultural ways of being, knowing, and doing in the world. Race is also correlated with an ethnicity, where race is broader and ethnicity is more specific. For example, white would be considered a broader racial marker, whereas Anglo-Saxon or Irish, or in the United States, European or white American would be considered more specific ethnic markers. Likewise, Black, Asian, First Nations, or Indigenous, and most recently, Latinx would be considered broader racial markers again in the United States. African American, Filipino X, Dene, and Chicana X would be considered correlating ethnicities. It is important to note that the association and or distinctions made between race, culture, and or ethnicity in these examples are not fixed or universally accepted. Thus, as noted previously, these concepts are conflated along with color, ancestry, nationality, and geography. Example B in the graphic on this slide illustrates the ideal hope of PGX testing, that it can be used to completely preclude adverse drug reactions. But the distance between this hope and reality is much greater than the graphic suggests. The focus of this special topic presentation is situated in that in-between space between the hope and the reality. Said another way, Kremski describes pharmacogenetics as a medical specialty field in which patterns of genetic variation are correlated with geographical ancestry, mapped onto historically based racial taxonomies to converge on drug treatment driven by genetic knowledge of patients' groups and eventually of individuals. So how did this field come about, and how personalized medicine became genetic and racial? Jones and Perlis noted that pharmacologists have long recognized that characteristics transmitted from parents to offspring affect drug reaction variability. In the 1900s, Archibald Garrod reasoned distinct genes govern distinct enzymes, and humans differed in their biochemical process as much as they did in their physiological process. According to Jones's work in personalized medicine, the 1950s tuberculosis scientists noted that individuals acetylated the drug isoniazid at disparate rates, which they could use to determine corresponding risk of side effects, specifically peripheral neuritis and hepatitis in slow acetylators and rapid acetylators, respectively. Stahl discussed how, throughout evolution, all species of animals have developed biological responses to eliminate foreign elements and environmental toxins, including medications. Of the many processes that affect the impact of drugs in humans, the cytochrome P450 system has garnered the most attention, within which isoenzyme 2D6 has been most extensively studied. P450 enzymes are responsible for approximately half of the removal of most frequently used drugs. Sujin Lee explains that the proliferation of traditional medicine, the goal has been the safety and effectiveness of drugs for the use by as many individuals as possible, whereas the pharmacogenetic medicine, the goal is specific drugs for specific populous subsets. According to Jones and Perlis, many factors influence the intricacies of the genetic underlying psychiatric disorders and medication reactions. Some non-genetic and environmental influences on drug metabolism include comorbid illness, age, gender, hormones, alcohol, nutritional status, herbal formulations, trauma, exercise, socioeconomic status, education, and smoking. For example, cigarettes can hinder neuroleptic and antidepressant concentrations up to 50%, and 1 cup of grapefruit juice can disrupt P450-3A4 from 24 to 48 hours, elevating levels of tricyclics, carbamazepine, clozapine, and lamotrigine. Sujin Lee notes that while race is most commonly associated with skin color, pigmentation is inadequately correlated to genetic background. Further, given convergent evolution, populations can share common skin color without sharing common or even significant ancestry. Despite this, according to Kremski, race is often used as a proxy for genotype, even though racial self-identification and societal imposed racial identification is subjective, influenced by cultural factors, and often not grounded in ancestral genomics. And even though there are no racial genes, no clear genomic divide between any society's socially constructed racial categories, and no stable cluster of medically relevant genes that is necessarily linked with ancestry or skin color. Race is also not a scientifically precise term for identifying relevant genomic or physiological characteristics that differentiate population groups. Accordingly, race self-identification or scientists assumed racial identification is not a reliable surrogate for scientific determination. Perhaps not surprisingly then, Jones and Perlis recount how pharmacogenetic data on race has produced inconsistent results. So-called racial group membership could supposedly be determined in slightly more than half of the FDA records for clinical trials on psychotropic medication. However, given that within those records, whites comprise almost 90% of patients, blacks, Latinx peoples, and other peoples of color represented the remaining 10% of patients, it is difficult to assess the actual efficacy of this determination. As a consequence, there is minimal data to inform decision-making regarding effectiveness or favorable dosages for psychotropic drugs in different populations. Looking again at the graphic on the slide, and then considering example A, relative to the noted FDA clinical trials on psychotropic medication, and relative to the information about PGX testing baselines noted in Dr. Hamilton's pharmacogenetic overview lecture, as with example B in the graphic, what is represented may be the ideal but is not the reality. The example suggests that clinical trials have roughly equal numbers of people from the different patient groups, including presumably racial groups, when the reality is that most clinical trials include mostly white people. As alluded to in the previous discussion, this is not a new phenomenon nor unique to psychiatry or to PGX testing. Race has been misused in medicine for many years. For example, according to Alsan and Wanamaker, in the Tuskegee syphilis experiment conducted by the U.S. Public Health Service over a 40-year period from the 30s to the 70s, scientists initially failed to treat African American clients with syphilis in order to observe the progression of syphilis, even though penicillin was available and known to be an effective cure. In the persistence of racial disparities in prescription of first-generation antipsychotics in the USA, Cook et al. Note that many more recent studies document that African American mental health clients are given greater doses of neuroleptics, are less likely to get atypical antipsychotics, and are more likely to get injection formulations than are their white counterparts. While pharmacogenomics promotes individualized care, clinicians need to be cognizant that in using pharmacogenomics, they may be inadvertently and erroneously applying population differences to individualized patients based on socially constructed categories of difference. In encouraging caution in clinical application, Streetman describes how carbamazepine labeling advises testing for HLA-B 1502 in the Asian population as a whole prior to the use due to potential severe skin reactions. However, while the HLA-B 1502 variant is prevalent in many Asian populations, among Japanese and Korean populations, it is found less than 1% of the time. Streetman further warns against the misinterpretation of data and applying it universally in discussing how people with extra copies of the CYP2D6 gene can be at risk of death due to the uncontrolled transformation of coding into morphine in their systems. People with this characteristics are found in greater numbers in North Africa than in sub-Saharan Africa, but again, these risks are noted for all people of African descent, including African Americans. According to Kremski, in 2005, the antihypertensive drug Bidil was approved by the FDA and became the first drug labeled exclusively for racially identified populations, namely people who self-identified as Black. I would argue that the characterization of Bidil, the first race drug, is a misnomer. It is the first race of color drug. If the white population is the default medical reference group, including for medications, clinically trials, and PGX testing, then all drugs have been race drugs, white race drugs. While they have not been overtly marketed as such, they have operated as such. Kremski notes that Bidil is part of a trend that has been reinscribing racial taxonomy either through geographical ancestry or indigenous populations into science, but does this without credible genetics. I would argue that racial taxonomy has never not been inscribed into science. As previously discussed, scientists codified race and perpetuated the myth of scientific basis of race. At the same time, scientists have challenged the scientific basis of race while simultaneously rationalizing the use of white people to establish all medical baselines. Sujin Lee articulates that the gold standard in PGX testing will be a race-obsolete, tailored genetic analysis of consequential polymorphism. Hopefully you found this special topics presentation interesting. In closing, as a bridge for the discussion forum, I have restated my original reason for selecting my topic focus, my why, along with 3 related questions that I thought might be good discussion starters. However, if these questions do not inspire you, of course, please share ones that do. These references supported the content of my presentation. These references support the graphics in my presentation. Thank you for your time and attention. Look forward to engaging you further on this topic in the discussion forum.